I'm going to do a question involving the Hungarian algorithm and a 4x4 matrix. So here we go. First thing we do when we've got these matrices, let's just work out what it means. We've got A, B, C, D, and these represent four different people. And then 1, 2, 3, 4 at the top represents 4 different activities. And the numbers in this case represent the hours that these individuals take to do it. And the whole aim of the exercise is to get the minimum number of hours required to do these 4 activities by allocating correctly each person to the job that they do the most efficiently. So we'll choose A, B, C and D so that we get the minimum number of hours. That's the whole reason for doing this thing. Okay, let's make a start. Firstly, we make all the numbers smaller as best we can by doing row reduction and then column reduction if we need it. So row reduction, we'll start at the top row, 3, 21, 17 and 2, and take away the smallest number from everything. And the smallest number is 2, so we will end up with 2 take 2 is nothing, 17 take 2 is 15, 21 take 2 is 19, and 3 take 2 is 1. Second row, the smallest number is 4, take that away from everything, and you're going to get 5, 23, 0, and 8. Third row, 11 is the smallest number, and so we're going to get 8, 4, and 3. No, 11 is the smallest number. That 4 is not a 4. That 4 should be a 1. There we go, careful. And then I've got 3 here, that was right. Okay, third row, 6 is the smallest number. And then that'll give me 12, 25, 6, 14, and 18 take away 6 is 12. Okay, I've done row reduction, I've got a 0 in every row, but I can see in this first column I don't have any zeros. Now you want a 0 in every row and every column, so you're going to have to do here a column reduction. I might just go to the right, so I'm going to go this way. I'm going to do a column reduction on the first column. The smallest number in the first, so that's 1, 5, 8 and 12. The smallest number there is 1. I'm going to take that away from everything, so I'm going to get 0. And then 1 away from that is 4, and that is 7, and that is 11. The other columns are all good, so I'll just write in what we've got. 19, 23, 0, 0, 15, 0, 1, 14, 0, 8, 3, and 12. Now the test for the Hungarian algorithm. I have to draw vertical or horizontal lines and cover up all the zeros in as few number of lines as possible. Okay, well, let's go across. Looks like it's only going to take 3 because we can go 1 that way, 1 that way, and then 1 that way. And I have covered up all the zeros. I've covered up all the zeros with 3 lines. Because I've done it in 3 lines, I have to use the Hungarian algorithm. In a 4x4 matrix, if I have to take 4 lines to cover it up, I'm finished and I go to the allocation stage. Because it takes less than that, it only takes 3, I must use the Hungarian algorithm before I'm ready for the allocation. Okay, here we go. For the Hungarian algorithm, you find the smallest number that is not covered up. So that's, I've only got 7, 11, 1, 14 and 3 and 12 to choose from. They're the ones that are not covered. So of those, here we go, 1 is the smallest. You find the numbers that have been crossed over twice. Now that would be 19 and 23, and you add that 1 on to each of those. So that instead of 19 will now be 20, and that 23 will now be 24. All the others that are covered up, once you just leave them. All the numbers that are uncovered, you take that 1 away from them. So we're going to get 6 there, we're going to get 10 there, 13, 11, 2 and 0. And let's see what our matrix now looks like. So I'm going over here, we've got 0, 20, 15 and 0, 4, 24, 0, 8, 2, 10, 0, 13 and 11. Again, we must do the test. How many straight lines will it take, vertical or horizontal, to cover up all the zeros? Do it in as few as possible. And I think we can still do it in 3, because I can go across there, that's 1. There's 2, and there's 3. And because I can do it in 3 and not 4, I'm not finished. I have to do the Hungarian algorithm one more time. Here we go. You look for the smallest number that is not covered up. That's from the 4, 6, 10, 8 to 11. What's the smallest number? It's a 2. You add that on to everything that is covered up twice. So that's the 20 there becomes 22, and the 15 there, add 2, becomes 17. All the other things that are covered up once, you leave it just like they are. This 2, you now take away from all the numbers that are not covered. So that'll be a 2, take away that, 6, 4, and 10, 8. That'll be 9, that'll be 0, and that'll be 6. So what I get after that is 0, 22, 17, 0, 2, 24, 0, 6, 4, 0, 0, 0, 8, 0, 13, and 9. Test again. Let's see how many straight lines it's going to take to cover up all the zeros using horizontal and vertical. Well, if I do 1 there, that got rid of 3 of them. 2, 3, 4, 2, 3. It's going to take 4 lines this time. 2, 3, 4. Okay, it took 4 lines this time. Because it took 4 lines and I have a 4 by 4 matrix, I have now finished the Hungarian algorithm. I now go to the allocation stage. That is, I've got to decide which person's doing which activity. Well, remember, we've got person A, B, C, and D. We've got activities 1, 2, 3, and 4. And now the zeros represent how the allocation is going to go. So if I draw one of these little graphs, we've got person A, B, C, and D. And we've got activities 1, 2, 3, and 4. Right, person A, because of the zeros, we've got a 0 there and a 0 there. Person A can do activities 1 and 4. 1 and 4. Person B can only do activity 3. Just careful. Only do activity 3. That means person B is definitely doing activity 3. Person C can do 2, 3, or 4. Okay. Person C can do that one, or that one, or that one. And person D can only do activity 2. Okay, well, if person D can only do activity 2, D is definitely doing 2. I've just got to decide about which one's person's. Well, person A can do 1 or 4, and person C can do 2 or 3 or 4. Okay, well, in that case, activities 2 and 3 have already been taken up, so those are done. 2 and 3 are finished. The only person left who can do activity 1 must be person A, and that leaves person C to do activity 4. And we have our allocation. This is the minimum allocation, the most efficient. To work out the number of hours it's actually going to take us to do these 4 tasks, the minimum time, let's go back to the original one. We've got A1 and B3, A1 and B3, and then we've got C4 and D2. C's doing 4 and D's doing 2. And the minimum time then is those numbers added together. So we've got 6 and 4 is 10, 24, 27, hours. So the minimum time 27 hours, and that's it. So there we go. This one was, you know, a little bit longer just because I had to do the Hungarian algorithm twice, but the method is the same each time. Okay, that's that.